In this video, I have a super quick tutorial showing you how to create a multi-agent chatbot using LangGraph MCP and open source to build a powerful agent chatbot for your business or personal use. Not long ago, I made a video about Model Context Protocol. Some developers compare it to Zapier built for AI, believing it simply adds extra steps to API usage. Before MCP, developers had to write code and connect AI tools to external systems through APIs, which meant that each integration needed to be coded up front. Although MCP was released last year, it has suddenly become popular recently, which has also sparked discussions about how long its flowering period can last. LangChain also launched a vote on X. The results showed that 40.8% of people believe that MCP was the future standard. 25.8% believe that MCP was just a flash in the pan, and the remaining 33.4% chose to wait and see. MCP is still new, released in November 2024, but it already supports many services such as GitHub, Slack, and PostgreSQL. Since it is an open standard, it is surprising that it can be used with any LLM. So let me give you a quick demo of a live chatbot to show you what I mean. I will ask the chatbot two different questions. The first one is, can you write a report about the latest LLM? Feel free to ask any questions you want. If you look at how the chatbot generates the output, you will see that the agent uses its structured flow, powered by the create chatbot function, to process input. This function integrates system instructions, user messages, and tool execution into a smooth interaction process. It then decides which tool to use based on the query. It will invoke the Google search tool to search for the latest information and generate the report. For the second question, write a Python script that uses Seaborn to create a scatter plot with regression lines. The chatbot processes the request and routes it to the appropriate tool, such as the Python REPL or data visualization, depending on how the query is structured. The async tool executor dynamically handles tool calls, ensuring that both synchronous and asynchronous functions, like generating code or visualizations, are executed properly. Throughout this process, the chatbot state graph manages conversation states, so it can provide accurate and contextually aware responses to follow-up questions. The getTools function ensures that only functional tools are available, maintaining system stability. The main function keeps everything running smoothly, processing user inputs, invoking the correct tools, and handling outputs in real time. So, by the end of this video, you will understand what difference between MCP and function call, when to use function call and MCP, and how we're going to use LangGraph, MCP, and open source to create a powerful agentic chatbot. Definitely stay tuned throughout the end of this video. If you guys haven't followed me, I highly recommend that you do so you can stay up to date with the latest AI news. Lastly, make sure you guys subscribe, turn the notification bell, like this video, and check out previous videos because there is a lot of content that you will definitely benefit from. So that thought, let's get right back into the video. In function calling, the AI is like a skilled worker operating under a strict script. It can fill out forms and call predefined tools, but only those it has obtained, and call them one by one. In MCP, the AI is more like an agent with a toolkit. It can rummage around in the toolbox, discover new tools, combine them, handle more tasks, and have greater autonomy. Function calling is tightly coupled to the prompts of the model and requires developers to manage the order, which makes it very controllable but inflexible to some extent. MCP achieves loose coupling through open protocols, which makes it highly flexible and extensible, but requires a strong design to manage complexity and ensure safety. The next section will dive into how to build an agent with MCP and how to deal with the challenges that come with this flexibility. So, when to use function call and MCP? Use function calling when you have a small set of well-defined actions or queries, especially if they are single-step operations and you want highly structured outputs. It's a good fit for predictable tasks and lightweight integrations where the added overhead of MCC might be overkill, so choose function calling when structured. Narrow tasks and ease of integration with your app are critical. Use MCP when you need greater flexibility, a versatile tool, or context that evolves across interactions. MCP is better suited for complex multi-step workflows, or when the AI must maintain long-term context and interact with a variety of systems. If your AI agent is a general assistant across internal systems that can draw on multiple data sources. So, it's important to note that these two approaches are not mutually exclusive. They can complement each other. For example, function calling can be used inside an MCP client to process the structured output of a model. But conceptually, function calling is designed to translate natural language into function execution in a controlled way, while MCP is designed to provide a broader interface for AI to explore and operate in an environment. Let us now explore step by step and unravel the answer to how to create the MCP app. We will install the libraries that support the model. For this, we will do a pip install requirements. The next step is the usual one, where we will import the relevant libraries, the significance of which will become evident as we proceed. LangChain MCP adapters. Convert MCP tools to LangChain tools for use with the LangGraph agent and provide a client implementation. Allows users to connect to and load tools from multiple MCP servers. MCP is an open protocol that standardizes how applications provide context to LLMs. And Google Search Python is a package to facilitate Google searches. I designed the create agent function as an asynchronous process to build an AI agent. I set up an async function that takes docs.info as an optional parameter to provide relevant data to the chatbot. I integrated multi-server MCP client into an async with context manager, ensuring seamless communication with an MCP server using server-sent events with a 30-second timeout. I implemented a call to the client.getTools to retrieve the necessary MCP tools, enabling advanced functionalities. To manage conversational states, I built a state graph using messages state. I then created a chatbot node with create chatbot, allowing it to process and interact with the provided documentation. I designed async tool executor to dynamically process tool calls by taking state as input, which contains a list of messages exchanged in the conversation. I extract the last message to check for tool calls, retrieving them from tool calls directly or within additional quags. If no tool calls are found, I return the messages unchanged. To process tool calls, I copy the messages into new messages and iterate through each tool call, extracting tool name, tool args, and tool id, supporting both dictionary and object formats for flexibility. I search for the corresponding tool by matching its tool name with available tools. If not found, I generate an error message listing valid tools. If the tool exists, I determine whether it's an async function using asyncio. Is a coroutine function. If async, I execute it using the await tool.coroutine. Otherwise, I call tool.func or tool. I handle errors by catching exceptions and appending detailed error messages to new messages. I designed a structured conversational flow by integrating an async tool executor node and a routing function into the chatbot's graph. First, I added the async tool executor as a node named tools, allowing the system to process tool calls dynamically. Then, I created a router function to determine the next step based on the last message in the conversation. The router inspects whether the last message sent by the AI contains tool calls. If found, it directs the flow to tools. Otherwise, it ends the conversation. To establish the flow, I added edges to the graph, starting from chatbot, conditionally routing to either tools or end, and looping tools back to chatbot to enable multiple tool interactions. Then I created a function called getSystemPrompt to dynamically generate a system prompt for the AI assistant, ensuring it operates with clear guidelines and contextual awareness. First, I formatted the current date using datetime.now and embedded it in the prompt for real-time reference. Then, I defined the assistant's role and capabilities, listing 3 primary tools: generate image, data, visualization, and Python replo. I developed the create chatbot function to handle user inputs and generate AI responses. It uses a technique, chat prompt template, to combine system instructions with user messages. The system instructions come from getSystemPrompt. I piped the prompt into an LLM to create a seamless processing chain. The function ensures message format consistency by converting strings into human message objects. The chatbot invokes the LLM with user messages and appends the response. It maintains a structured conversation history. The assistant follows predefined rules while adapting to queries. It remains tool agnostic, allowing flexibility in responses. I developed a set of tools for generating images, visualizing data, and executing Python code within a multi-tool system. The Generate Image tool uses DALL-E to generate images based on a prompt. It ensures the prompt is valid and then makes an asynchronous call to the OpenAI API to generate the image. If successful, it returns a URL to the generated image. If an error occurs, it provides an error message. The Data Visualization tool executes Python code using Matplotlib to create charts, saving the result as a base64 encoded PNG image. The Python REPL tool runs Python code using a REPL environment, providing dynamic execution of user input. Each tool is designed to handle errors and return meaningful responses to the user. I created the getTools function to return a list of tools that are available for use, ensuring only functional tools are included. The function starts with a base set of tools: Generate Image, Python REPL, and Data Visualization. If an additional retriever tool is provided, it gets added to the list of tools. The function then returns the complete list of available tools. Finally, the script runs the MCP server using server-sent events as the transport method by calling mcp.run. I then designed the main function to run an asynchronous agent that processes user input and interacts with tools dynamically. The function starts by creating an agent and a client with awaitCreate.agent. It then prompts the user for input via the command line and constructs an initial message with the user's request. The function proceeds by invoking the agent asynchronously using agent.invoke, processing the request and handling responses. If the response is from a user, it prints the user's input. If it's from a tool, it prints the result and checks if it's an image generation, extracting the image URL. Any exceptions during processing are caught and printed. Finally, the client stays alive to ensure the operations continue. MCP is not just a simple upgraded tool calling protocol, but a major paradigm upgrade. MCP provides a common open standard that enables AI systems to connect to a variety of data sources, tools, and services in a standardized way, which reduces the need to build separate connectors for each data source and simplifies the AI integration process. Current non-intelligent services can expose their own functions as tools through MCP for LLM to call, which enables LLM to interact with existing systems and perform tasks without major modifications to existing systems.